Hello everyone. In last video we have discussed equations of motion using algebraic method, and in this video and coming videos we will discuss using the same equations in graphical method. These are the equations we want to derive. Let us consider this graph, what it indicates. There is u is the initial velocity of the object, v is the final velocity, t is the time interval t, a is the acceleration, s is the distance traveled by that object. Now there are two questions can come up from this graph. First question is why we have taken initial velocity which has certain magnitude, why it is not zero. Initial velocity, why we have not taken it as zero. And second question, why this line has drawn with a positive slope and why it has drawn inclined, why it is drawn inclined, why it is not horizontal. Okay, so let us answer the first question. If I take initial velocity 0, anywhere in out of these three equation, if I take u answer is 0, that u term will cancel out, right? So u is 0 means that term won't be there. And second is, if I take this line horizontal, second question if I want to answer, if I take this line horizontal, in that case u and v will become equal. So u equal to v. So again, in any of this equation, if you take u equal to v, both u and v will cancel out. Even in this equation also, if I take u equal to v, u and v will get cancel out. So we want a general equation or generalized equation where all terms exist. U exists, v exists, s exists, a exists, t exists. Keeping that in mind, we have taken u which has some magnitude. No, we have not taken u initial velocity as 0, and we have taken u this this graph or this line we have taken which has a positive slope. Or from u to v we have taken velocity, it is increasing. If you take velocity constant, then there is no point because u and v will cancel out, u and v term won't exist there. So that is the two questions, very important questions. Now we know in distance time graph and velocity time graph, in distance time graph the slope of the line, it gives us the velocity, and in velocity time graph slope of the line, it gives us magnitude of acceleration. And slope, the third thing is, in velocity time graph, if you consider the area under the line, it gives us the magnitude of the displacement. These are the three thumb rules, basic outcomes we know from the distance time graph and velocity time graph. Same logic we will follow here. For this velocity time graph, what we have drawn here, the slope of that velocity time graph will give us acceleration. Let us calculate that acceleration. Acceleration is equal to, or the slope of this line is equal to, obviously it will be BC divided by AC. So what is BC? BC distance is nothing but BD minus CD. BD minus CD. Now, what is BD? B to the distance is nothing but distance V, final velocity V, and CD is nothing but the initial velocity U, and AC is nothing but the time interval t. So acceleration I can write as V minus U divided by t. A is equal to V minus U divided by t. Now this t I will take it to the left hand side. So AT is equal to V minus U. Now this minus U term I have taken to the left hand side. So it will give U plus AT is equal to V. Finally I can write V is equal to U plus AT. So this is the first equation of motion. Simply what we have done here, the velocity time graph, the slope of that line we have considered. Initial velocity we have not assumed 0. We have considered that initial velocity has a certain magnitude, and the velocity, it is increasing with respect to time. Initial velocity and final velocity are not same, or u and v are not equal. V is greater than u. So that assumption basis we have derived this equation of motion. First equation of motion we have derived. In coming videos, other two equations we will derive. Thank you.